Hello, welcome back again to NX Progressive Die tutorial. So in this session I would like to show you the motion simulation for the progressive die. Okay, so one thing you should do is pre-process motion, and then we going to adjust all the numbers in here in order to make a good simulation. So it also will asking the pre-process motion, the category top, bottom, lifter, stripper, and the feeder. In here we have top, it means the top of die. Bottom half, the lifter, include pilot lifter, pilot guard lifter, and all the lifting object in here. The stripper is the plates in here. The stripper, the plates, the stripper plate for both upper and lower die assembly, and the feeder is the strip layout, that we already made before. Okay, let's try this. Now in here I go to pre-process motion. You see here there's a add kinematic model. Okay, now automatically NX will fill in the all the numbers in here, okay, based on the geometry. And this is the information what is A, B, C, and D. Okay, now after that I click apply. Okay, tooling kinematic single strip model, click apply again, and then I go to mount component. In mount component, NX will automatically will recognize and make classification like I already show in here. So in here, for example, if I uncheck all, you can see this is the feeder, the strip layout. You see the feeder. This is the stripper, so it's a part of upper and lower die. Okay, you can see this is the lifter. It's a part of the pilot lifter and the pilot guide lifter, and this is the bottom part of the dice assembly, and this is the top part of the dice assembly. So if you agree with all of this, it means you can click OK. So NX automatically will create all the parameters. The next thing we should do now is to run the simulation to check is it correct or not. If not, we're gonna make some adjustment. Like this one, you can see it's too high. We can adjust later. We can see the simulation now. The stroke is too far. Okay, in here you can see the lifting is also not too high, but the stroke is far too high. So it means we have to make some adjustment. In here the C is too small. Maybe we should add 20 millimeters. But the distance, the total D is A plus B plus C. Maybe the stroke we add about 100. So we're just going to do the estimation first, and then we check again the kinematic model. The stroke is still too high. But the lifting is already good. You can see there's no interference between this bending, so I think it's enough. So it means we go to the lifting. So in here, machine stroke is 100T plus A plus C. Maybe the A staple travel, lift height maybe I should add maybe about 23, so slightly higher. Let's check. You can see. Okay, understand. Stop. Okay, it lifting here. But you can see now when it move, this will start to touching, so there's gonna be interference. So it means the lifting 50 millimeters too small. Going back again, maybe about machine stroke about 80. Too high. Too high. So the stipple, it stop here and then it start to punch. So we return again. So it's almost like a trial and error. Now it's still too high at the beginning because it's moving outward, so maybe the strip lift height is too high. We're going back into 20. Maybe this is about 72. No gap, still a little bit higher. Okay, so the plate stop and it start to punch. Okay, make some small adjustment again. Stop about 70. See, it's still a little bit high outside from the here, but maybe we should check the configuration again. So mostly is a good one. Let me run the simulation. Okay, close, and let's check with the upper die hidden to see all the sequence, is it correct or not. Oh, we should hide also the additional tool. So what we're going to hide now, we're going to just only show the piercing, the bending, embossing, all the lifter, all the pilot. Okay, so we're gonna check the process itself. Okay, it will be better if I also show the low dice, make more realistic. Okay, let me explain a little bit. So in here we have the pilot piercing hole, and then after that it travel in here. We have a piercing. Okay, in here also we have a piercing. And here also, in here. After all this hole generated, now it's time to split between parts using this piercing punch. And then in here you can see also it create a forming, this one, and then there are some special tool for piercing, some of it not shown. In here we have a forming, so the part is travel from here to here. We have the forming, first forming here, you can see. The second forming create two cylindrical shape like this. And also we have special piercing here, but it's hidden. Maybe I'm gonna show later. The final for the forming is to create this object. Now in here you see it start a bending operation, a V-bend operation, and also in here we have angle bending operation from flat to angle bending. Okay, now in here we see 90 degrees bend. So in here, as you can see, there are some static interference, so it means that in here you have to change a little bit, make some modification. So it still need to refine the design. In here you can see there are 90-degree bending also, and the final is to trim into the final product, this one. Okay, so in here you can add some optional equipment to hold this final product. Okay, so I think for the motion simulation is complete. Now I will go to bill of material. So in NX also, in here we have automatic bill of material. So it have all the components, the stock size, the quantity, something like this. For example, the supplier, the name of supplier. Okay, the description also here, and it have a BOM type 1, type 2, so it's up to you, and you can export it to Excel, to the spreadsheet, so it will automatically create the Excel. And you can change the title, you can change the format, and so on. So I think that's all, the basic progressive die tutorial for me. So I hope you can practice by your own, and I hope it's gonna be useful for you. Thank you very much for your kindly to watch all my movie.